Optimized geometry can make the difference between a visually stunning and highly performant real-time walkthrough and one that is lackluster. Geometry with overlapping faces, flipped normals, T-vertices, and overly high poly counts, among other issues, can cause materials to render poorly and can cause frame rate loss on lower-end hardware, or in virtual reality, which requires 90 frames per second to avoid simulation sickness. That means each frame must render at 11 milliseconds or less to maintain a good virtual experience. Let's take a look at some common geometry optimization tricks and debugging tools that will help you avoid these issues. First up, let's talk briefly about quads versus triangles. Now, you can use quads or triangles with Unreal, and you probably won't see any issues. The only real reason to use quads over triangles is that, by doing so, if you need to subdivide a mesh or reduce its complexity for an LOD, it's going to do so in a much cleaner fashion generally. It's a lot easier to subdivide or reduce the quality of a mesh that's made up of quads. Because if you're going to increase the complexity of the mesh, it's very easy to subdivide it into a version that is just as clean as the original version of the mesh. As well as LODs, when you're reducing the complexity, quad-based meshes will reduce a lot cleaner than meshes that are composed purely of triangle soup. So for instance, we see this couch here, which is all triangle soup, and you've got some quads in here, you've got some triangles. It's very messy. So if you wanted to subdivide this, it's not going to do a very good job. If you want to ensure that your mesh is going to render well in real time without any kind of shading issues, it's best to stick to quad-based meshes versus triangle soup like this. Now, obviously you want to avoid things like overlapping faces, which can cause Z-fighting, and you want to avoid T-junctions. Basically, anything that looks bad in your 3D tool, whether it's Max or Maya or Blender, that's going to look bad in Unreal too. So be sure to clean that stuff up using your basic mesh cleaning tools. I know with 3ds Max, you have the mesh inspector, which will automatically look for these kinds of errors. You can also enable the X-View settings in your viewport to check for things like face orientation, overlapping faces. We can see here we don't have any in this scene. This scene is a very clean scene, well put together for the most part. We can also look for things like T-vertices, overlapping vertices, isolated vertices. Anything, again, that is going to look bad in your 3D tool is going to probably look bad in Unreal too. So be sure to clean that stuff up. Likewise, you'll want to check for flipped normals in 3ds Max here. That's as simple as entering subobject mode and then checking show normals, so I can make sure all my normals are pointing in the direction that I want them to point. Obviously, if there are any normals pointing into the geometry instead of out of it, you need to use a tool such as the flip normals tool, flip those normals. Otherwise, it's going to look incorrect in Unreal just as it would in the 3D tool. Now remember, in real-time environments, you need to maintain 30, 60, or even 90 frames per second if you're doing virtual reality. And that is going to come at a cost to the complexity of your objects, and that includes material complexity as well as the complexity of the geometry. Now, Unreal and modern video cards do a fantastic job of rendering out a large amount of polygons. But of course, if you have a whole lot of objects in your scene, hundreds, thousands of objects, and they're all thousands of polygons each, or it's a very large scene with a lot of objects, you do have to consider your poly counts. So in the case of something like this carpet here, you really should be only using the amount of polygons that you need. This is something that's not always taken into consideration when you're doing renders, but for a real-time object, this flat object here is probably a little over the top in the poly count. So we'd want to use mesh reduction tools to bring this down considerably. Now there are some things we can do in Unreal to find out whether or not we're going to be able to maintain a good level of performance. Let's take a look there. So first off, in the Unreal viewport, we can actually enable some stats so we can see how well it's running. So we'll just hit the little down arrow here on the top left corner and choose Show FPS. This is the very basic amount of information we can get here. So we can see I'm running at about 100 frames per second, maintaining roughly 9 to 11 milliseconds. And that is perfect because that's basically VR level of performance that we need here. If we ran this in a VR headset, we'd be looking great. Everything would be nice and smooth. We wouldn't get any simulation sickness or motion sickness. So that's perfect. We can also get a little more detailed information if we go under Stat, and then we can look under Advanced here or under Engine. We can also find out about the entire scene. We can see all the details on each object and what the entire scene is composed of. If we click on Window and then Statistics, Now this brings up basically a spreadsheet of all the static mesh objects in our level here. We can see we've got 94 meshes, and then we can see how much memory they're taking up. We can also see the number of triangles for each mesh. So we can see here we've got some really high count ones here. This couch, these are obviously the two couches. They're 91,000 triangles. We might want to reduce those. Also, we can open the static mesh editor and get some more details on the object. So we can see here our couch, and then where it says triangles on the top left here, again, 91,472, 57,000 vertices, and that gives us an idea of the count. We can also turn on wireframe to get an actual visual representation of the polygons on our couch here. So the point is that you want to make sure that you maintain that high frame rate for a real-time walkthrough. Especially if you're doing VR, you've got to maintain 90 frames per second. It's basically a rule set in stone for any good virtual reality simulation. Unreal Studio does a great job rendering your geometry even if it hasn't been optimized. In fact, this scene you're looking at here, there was very little optimization done to it. It was a clean scene to begin with, but it is kind of high on the poly count. Some of these objects are a little excessive for what they are. That being said, it's still a good practice to optimize your scene and follow good modeling techniques. This is going to save you time and frustration tracking down and fixing issues later that could be causing performance issues or graphical glitches. Just remember you've got a lot of debugging tools at your disposal in Unreal to help you make sure that your geometry is clean and your poly counts are reasonable. Alright, so up next, we'll continue with our discussion on performance and geometry optimization by looking at LODs.